All right. I still need permission to share the screen. Okay. Okay, give me a second. All right. Yeah, first of all, sorry for my delay. I was stuck in class until 5:30, so I just had to run here. But yeah, so welcome to the second part of Virtual Technologies History Survey and Classification. Before I start off with the actual presentation, there were a couple of questions raised last session, so on Tuesday, regarding the current trends in technology and like using brain input to manipulate things in virtual reality. And I tried with the limited time I had in these 2 days to look up something which might be interesting. Or might not be interesting, I don't know. But I thought I might just like present it to you guys before I start off. So I found a paper about brain-computer interfaces in virtual reality. And basically what this paper was about is they wanted to test how the brain input like would work in virtual reality. And they had like this hardware consisting of 3 things: the headset that consisted of a wearable EEG device, a VR headset, and a virtual interface. And the task for the users was to rotate or scale an object in virtual reality using either mental commands or facial expressions. And the results showed that mental commands were often inconsistent and persistent, while facial expressions were consistent and bursty. So in conclusion, research looks like is currently looking into brain input for virtual reality. This paper was from 2019, so it's not too old. And it kind of shows that we're moving into that direction, but we're still in the infancy stage of using brain input, because there are some issues with the tracking currently. And generally even the hardware of how we can like use, there were like 14 electrodes or something used in this headset. And this one was well suited to wear under the VR helmet, but as manipulation also progresses, it might get more difficult to find suitable hardware. So trends are going into that direction, but we're still far from there. Yeah, I hope that answers maybe some of the questions I just thought I might quickly talk about this paper. But let's now actually start with the content for today. This is not today, this is last week. But basically what we did on Tuesday is we had a look at what virtual reality is, the perfect virtual reality, a couple of definitions, and then looked at keywords to remember, which were imagination, interaction, and immersion. We had a quick look at the history of virtual reality, and then finally one way to classify virtual reality, which were according to the immersion, non-immersive, semi-immersive, or fully immersive. And then finally, we concluded with a look at the virtuality continuum. And what we do today is we will have a look at virtual reality methods, applications, locomotion techniques in virtual reality, and virtual reality challenges. So yeah, let's start off with the methods. So there are 5 methods that can be used to create a virtual reality, which are simulation-based virtual reality, avatar image-based virtual reality, projector-based virtual reality, desktop-based virtual reality, and head-mounted displays. So what simulation-based virtual reality is it's a virtual reality system that involves computer-generated simulation of a real world, or like an approximate imitation of the real world environment or situations or phenomenon. So learning mainly is one of the most popular applications for a simulation-based virtual reality. Examples would be like a driving or a flight simulator, where pilots or drivers are drawn into a simulated environment that gives them an actual impression of driving or flying a plane. The other method that can be used for virtual reality is avatar image-based virtual reality. And yeah, within avatar image-based virtual reality, you basically can create a graphical representation of yourself and use this so-called avatar then to interact also with user avatars from yeah, other users. And the application from avatar image-based virtual reality centers primarily on incorporation with other types and methods of virtual reality, such as in the case of placing avatars in a simulated environment, for instance. Then we have the projector-based virtual reality as a third method. The image might be familiar to you guys. It kind of reminds of the cave, which we came to know during the history lesson. So you have projections that are used to create this yeah, immersive virtual experience, which draws users into the simulated environment modeled after a real environment. And there can be some overlaps with the simulation-based virtual reality system. However, the main purpose of projector-based virtual reality is only to draw like the users into a realistic-looking virtual environment. Then we have the desktop-based virtual reality, which goes into the direction of non-immersive virtual reality, partly. And it is basically where we display a three-dimensional virtual world on a display device such as a desktop or a handheld display. And the differentiating feature here is that the virtual reality system focuses on providing computer-generated visual perception, and it does not use any other sensory input components, such as positional tracking equipment, for instance. And it does use first-person video games, for instance, as an example, for this desktop-based virtual reality. And lastly, as a method, we have head-mounted displays, and head-mounted displays are more or less the most advanced method to employ like a fully immersive virtual reality, and it can transport users into a seemingly enclosed 3D virtual world. Head-mounted display mostly include positional tracking, audio inputs and output components, and haptic feedback to really create this full immersion of virtual reality. And with that, we conclude the virtual reality methods already, and we can proceed to the virtual reality applications. So there are loads and loads of forms of applications for virtual reality. These are just like a couple to name them, but there are like a lot. So currently virtual reality is used within the automotive industry, for instance. It is further used in healthcare. You can use it in education and training. You can use it for real estate, architecture and interior design, further retail, also in sports. There's also virtual reality for arts and design. We've seen like collaborative virtual reality for the social component. You can use virtual reality for meditation as well, like that would go into fitness and well-being. We have virtual reality also, like there's some form of virtual reality recruitment going on as well. And as we know, there's a lot of virtual reality employed in the entertainment sector and also in the tourism sector. As there are like a lot of different applications, I will talk a little bit more about like the first three applications I've named here. And the first one is the automotive industry. So let's have a look at how virtual reality can be used in the automotive industry. So there are mainly 4 use cases for virtual reality in the automotive industry. And the first is that it can be used for virtual prototyping and design. So basically, it is currently used, like sketches are mainly done on like desktop so far, like in 2D, but virtual reality can help out to really create this 3-dimensional model. So currently it is more used as an addition to the 2 dimension. So I've seen like videos where people are prototyping cars in 2 dimension first, and then they use the 3 dimensionality, and they just like use it both. So they can draw something in 3 dimension and then correct it in 2 dimension again. So just use both forms of input to really create this design or prototype. Further, virtual reality in the automotive industry is also used for training purposes. So yeah, like in the assembly line, people, workers there can be trained to where which screw, for instance, belongs, or how to assemble stuff together. Yeah, so they can basically train before they would actually do something wrong, or kind of just stop this entire flying process, and would not even need like human resources to actually teach them, because they could be taught in virtual reality in the beginning at least. Then another use case for virtual reality in the automotive industry is like our showrooms. So you can imagine, I don't know if any of you has tried to buy a car before, but usually like these car display stores, I'll just call them now, have a couple of models which you can have a look at. But if you want something really specific, or you want to have a specific color or something, they usually don't have it there. And virtual reality could help to kind of visualize how your dream car could look in the end. So you could create the color and the features and everything, and then you could have a look at the virtual car at least, even if they don't have the real car in their showroom. And lastly, another use case, which I found interesting, is that virtual reality can be used for the safety of self-driving cars. So unlike a human driver, autonomous cars must have massive predefined algorithms that will enable vehicles to handle absolutely any situation. So with autonomous cars, they basically need to drive around and kind of memorize all the different scenarios that can happen on the street to be prepared for them when they actually encounter them. And you can imagine that this process, if you would do it right, would actually take like a lot of years, which yeah, could be accelerated actually if we use virtual reality. So what it basically does is that virtual reality can create, like, these scenarios can be created in virtual reality, and this car would basically just drive around in the virtual environment instead of the real environment. And this makes it so much faster, this entire process, because manually you would like have to wait for a scenario to just happen. But in the virtual reality, you could just create these scenarios, and the car would be much faster in learning them. And also just much safer, because you're not having like putting this car out in the real world and kind of putting pedestrians in danger, because it just like stays yeah, at one place. So also you're like saving a lot of resources, human resources, but also like fuel and everything, because the car is just training in virtual reality instead of the real world. Okay, now you have to tell me if you can actually hear this or not. Yes, good. No, nothing. Okay, give me a second.
So stop the sharing, and when you start sharing again, there are 2 checkboxes on the bottom where you need to check that sound should be shared.
Okay, let's try this again. Okay, perfect. Yeah, there's not much happening actually in this one, but basically it's an example where you can see how virtual reality is used for training in the automotive industry. So basically here the instructions are just displayed via text instead of like audio or sound. And they just like have all their practice sessions. I'm just gonna skip through it a little. And you also see like how you can get also direct feedback already through at least informal text here. Okay. Oops. Yeah. So much for the automotive industry. Yeah, then let's continue with the use cases of virtual reality within the healthcare industry. So in the healthcare industry, there are like 3 use cases so far where virtual reality can be employed. And the first one is pain relief. So there's something called Ease VR, which is a system that uses cognitive behavioral therapy and other behavioral principles such as deep relaxation, attention shifting, interoceptive awareness, and others to aid the reduction of chronic pain. So what happens is that basically the patient kind of immerse in some environment which is calming to them. And it works with the principle that if you can distract your patients from pain, that might actually also like help towards the pain relief. So virtual reality can in that sense be used to help pain relief, and it is especially used for burn patients. Also in the healthcare system, as you see, training is like a major thing for which virtual reality is generally used. So it's also used within healthcare to train surgical skills, especially, which is like pretty like advanced because I mean, especially like for surgeries, it's a dangerous procedure which has an impact on a patient's life. So it's very helpful if surgical students, medical students have the chance to try out a certain procedure as often as they want to before they actually perform it on a patient. And again, here also it saves human resources because doctors can pay like more attention to the patients, while students can use virtual reality, first of all, to learn some of the procedures themselves until they like overlooked by the doctor then later. The third use case in healthcare is treatment for mental health issues. Again, this should remind you of the history timeline we had on Tuesday, where we had virtual Vietnam. So virtual reality is used in exposure therapy in the treatment of PTSD and anxiety as well, where war zone scenarios are, for instance, created within this therapy. And again, I have a short video which kind of relates to the training of surgical medical students.
Press the start button to begin.
Look at these x-rays. As you can see, this is a significant fracture missing.
So the good thing about like virtual reality in these medical trainings especially is that if you would just try them out on like a dead body or something, you would not actually be seeing the nerves or the insides. But here you can perform this, like here you see it, you can kind of perform it, and you can also see like what you would be hitting to really understand the entire process.
Place the forceps back on the track.
Oops. Yeah, and one more thing, I'm sorry, I hope that doesn't annoy you, but it just like keeps popping out of my ear. One more thing about the healthcare is maybe you saw that they're using dummies as well. So this is kind of to create this haptic feedback, which is still like lacking in most of the VR systems. So they have an actual dummy and actual instruments sometimes, but they would see it through the virtual reality to really understand like the nerves and the bones and everything, but they would still receive like the haptic feedback and like yeah, the precision what they would normally have. Yeah, and lastly, like I have the education and training sector, which I would want to have a more closer look where how virtual reality can be applied in this sector. And for the education, virtual reality can be used for teaching and learning. And there are different applications such as the rendering pipeline and virtual reality. I will be talking about that shortly. Also, I've seen an application for immersive vocabulary learning. So how that application basically looks like is that you have a virtual environment, for instance, your home, and you could walk around like in this virtual home and pick up different stuff. And whenever you pick something up, it kind of displays to you how this word would look like in, I don't know, for instance, Spanish. So you could walk around and pick up a book and it would say what a book basically means in Spanish. Another application is exploring space. So there are applications in virtual reality education used to take students to places which they could normally not go. So they're used to, for instance, take students back in history or like exploring space, which helps them to like really understand it from another perspective, which you could usually not even do. Even like this Aspen movie map, which we had in the history section, for instance, would be kind of an early example towards this, as the students could explore the roads of Aspen without actually going there. Also, virtual reality is used for some sort of collaboration and marketing. And there's something like called the virtual campus. So this is something that would have been very useful, like during the pandemic, for instance, where you have this virtual campus where students from all around the world could come together and study together without actually being together. So this is also based on like avatar image-based virtual reality, where you have an own representation from yourself and you can see your friends' avatars at least and kind of walk around and study together with them in this virtual environment. Further, there's like, there are a lot of applications in the training sector. Like we've already seen examples in healthcare and in the automotive industry. And why it is so popular in training is that you can use virtual reality training, and it reduces, like, you have no material cost, and it also reduces the risk for injuries. So you can use it to simulate dangerous situation and train within dangerous situation without actually getting hurt. And this is why it is like very popular in the education and training sector. All right, so as I've mentioned on Tuesday, I'm an exchange student from Germany. And this is actually my university and a couple of projects from my university, which I thought might be interesting to share with you. So on the right side, you see this rendering pipeline I was talking about. And what it basically is that you can, kind of learn the rendering pipeline in the every stage of the rendering pipeline within virtual reality. Students can use this VR headset. It's still a research project, so it's not actually being used. But you have this robot who kind of takes you through these different steps of the rendering pipeline. And in each step, you have a different form of interaction. And I have listened to like introduction to computer graphics without virtual reality before I had this class about learning technologies. And so I kind of really saw the difference between 2D CG learning and 3D CG learning. And I personally find it pretty cool because especially like with 3D, it's hard to grasp if you're just like studying it on paper more or less. And it's really like it stays in your mind if you are able to actually interact with stuff. So here you could like walk around, you could see objects from different perspectives. You could, like in the triangulation stage, you could actually draw triangles and create your own 3D models, and you could scale them, rotate them, and really interact. And through this like active learning, like you understand it much better than you would do by simple paper learning. So this is a project our university is currently still developing. And another project is the virtual reality classroom, which is in collaboration with a university from Potsdam. And it is meant to train becoming teachers basically on how to manage a classroom. So you have a lot of students in this virtual reality classroom who represent a real classroom. So some are pretty annoying, some are very loud, some, I don't know, are very into learning or something. So you have different personalities, and you as a teacher could walk around and kind of try to manage this classroom as a training. This is also like another short video showing this virtual campus I was talking about earlier. on how it can be used to study together.
And so war is escalated, and so the powers in Europe are escalated.
And what I find like actually cool about this
Turn to Westphalia.
application is that you also have this movement in it. So it's not like you're sitting only in a classroom, but you actually have this walking around, and you can do stuff like this.
Only a few of the original 300 million sperms have survived and managed to reach the egg cell, while this one is...
Okay, and lastly, I thought I might quickly just throw in my favorite virtual reality application, which is part of the, I would say, like arts and maybe enjoyment sector. Maybe you have heard about it, maybe you have not. It's called the Tilt Brush. I will also just like show you the capabilities, what it can do. Oops. So basically, Tilt Brush is like 3D painting and drawing. And there was actually like even an arts exhibition in 2015, I think, where like artists across the world have used Tilt Brush to create their own sculptures and everything. And you could have a look at it in virtual reality together, which I personally found pretty cool. Okay. And with that, we have also already concluded the application section. So as I say, there are like multiple applications, but I just like selected a few to just give you an idea of how it can be applied. And with that, we're moving towards the locomotion techniques in virtual reality. And this is kind of inspired from a lecture I also had in my home university, like from the media computing group at our university regarding human-computer interactions. Because walking or like general locomotion techniques are like the main form of interaction also, which are important in the virtual reality. So I thought whatever I learned there might also be interesting to you guys. So yeah, like as I said, the question when we think about virtual reality raises the question how to move through virtual reality. And the most instinctive answer to this would be let's just walk like as we do it in the real environment as well. But the thing is that walking is only possible in limited rooms, which are not larger than the tracked area. And also with walking, we have other issues such as the safety of a person so that you don't like walk against a wall or trip over something while walking. So another question which kind of is raised when we think about walking to kind of solve maybe some of these issues is, can we just make people walk faster? And there was research from Facebook when they bought Oculus Rift VR company back then, who actually looked into this question. And the research showed that speed increases by plus minus 25% are unnoticed by users. So instead of walking, I don't know, 8 kilometers per hour, you can walk 10 kilometers per hour in virtual reality to just accelerate this walking. Yeah, while they did this research, they further also found out that plus minus 5 centimeter height difference is also tolerated. which might be like useful, that if you place your camera across these 5 centimeters, like way above, you would kind of mess with the embodiment illusion, as we've learned it last week, because your body wouldn't feel really real anymore, that it actually belongs to you. So generally, another thing about like just walking is that our current tracking systems are not too advanced, that people in the long run kind of like users kind of start drifting off, and there's like a subconscious readjustment of this walking speed anyways to kind of compensate this drifting. So walking doesn't seem to be the best solution in virtual reality. So what else can we do to kind of resemble the locomotion techniques? And another option to actually walk around in virtual reality is walking in place. And that is actually a really good alternative towards walking, and is like widely researched nowadays as well. And in walking in place, there are 2 different types of walking in place, basically. And one is tracking based walking in place, and the other one is mechanical walking in place. And for the tracking based walking in place, you don't have any machines, but you have these sensors or straps around you. And you would basically just like do this high knees exercise, for instance, to just move into one direction or turn around like in your place, but you wouldn't actually be moving around. And this is a simple approach of kind of like, I wouldn't call it simple, but like, yeah, an intuitive approach to kind of realize this walking in place. But it kind of involves, for some of these realizations, also a lot of learning of like different commands at different postures and gestures. And also it doesn't feel too natural if you like just stay in place and just keep like walking in place. So there is this mechanical walking in place as well, which is more bulky and requires more hardware, but kind of offers a more natural walking in place experience. So you're secured in this machine kind of thing. So you could just like walk as fast as you want to, but you would still always stay in place. And that is possible due to these omnidirectional surfaces they have in the bottom. So it kind of just adjusts to whatever direction you would be running to. And I have like a small video also like sharing how this actually works. It's more like a advertisement kind of video, so you will see what I mean when I play it. Yeah, I'll just stop it here. Yeah, but basically you can see how it keeps the person secure, and you can run around without actually being worried or anything. And that is why it also feels real, because for you it kind of just resembles a treadmill where you just like keep running and running, but the harvest keeps you in place. Yeah. So yeah, like walking in place, as I said, it might seem pretty intuitive at first, but it is actually a very complex subject in research itself, because there are lots of parameters which you have to consider, such as the movement range, the walking surface, the walking style, and everything. Or like questions of like, how is the velocity control, or how is the steering control on walking in place? Yeah. So the last question that is raised is, what can you do if it is not possible to use your legs at all? So this kind of goes into the direction of how walking could be possible through the use of controllers, actually. And there has been, there are a couple of locomotion techniques that can be used using the control. And the first one is called arm cycling. So what you can do is that for walking is you can use your controller, and you could kind of start like doing these, like riding a bicycle with your arms just to get forward. So this is like one way of resembling these locomotion techniques. Another thing is called point tugging. So in point tugging, what you do is you basically place your controller towards the direction where you want to move. And then you would start press holding a button and just pulling the entire scene towards yourself. Then we also have teleporting. Teleporting basically means that you also kind of direct the controller to the direction you want to go. And through ray casting, you would be basically like jump to that direction or that place and be teleported to that direction. And finally, if you don't use any of these controllers, you can also use a joystick. And I mean, that is, I think, pretty well known from like video games or something, that you can just move it around to actually walk around with that. And there has been a paper that has been researching the performances of these different locomotion techniques. It's a paper from Kuma et al. And the researchers asked the users to kind of go on a treasure hunt in this virtual environment using these different kind of locomotion techniques. So let us quickly have a look at how the performances of these different techniques turned out. So they rated different variables. The first one was enjoyment. And the results basically show that arm cycling and joystick were the most enjoyable techniques, but also point tugging and teleporting weren't too far off. So generally, all seemed pretty equally enjoyable. The second thing they measured was the tiredness the participants experienced while using these interaction techniques. And you can see that joystick and teleporting had the best performance in this regard, whereas arm cycling was the most tiring, followed by point tugging, which is not surprising, because if you just like keep moving around with your arms, it eventually will get tiring. And also for point tagging, you have to like actually lift your arm and show it at some direction, just keep it in the air. While for teleporting or something, you could keep it closer, and joystick, you don't even need to lift it at all. Then also control was measured. And participants revealed that arm cycling and joystick provided the best control. Teleporting was actually the worst regarding the control of variable, followed by point tugging. Another thing they measured was the traveled distance. So it's not surprising that for teleporting, the distance is that large, because you can just like cast a very infinity wide, basically, if you wanna, and you can therefore just like quickly travel a long distance. Whereas for arm cycling, you cannot travel that far, but still arm cycling has the benefit that it actually resembles more or less real walking, because you have these small movements. It actually feels like it could be like taking small steps as you would usually be doing while walking. But with teleporting, it's hard to do the small distance, but it's very beneficial for long distances. And if you were wondering like about the time, so like the treasure hunt had to be completed in a certain time, but there was not a difference between arm cycling or teleporting actually regarding the time that was used for the treasure hunt. Finally, they also evaluated sickness. And I don't know if this seems surprising or not to you, but point tagging was very, very bad in this regard. So people actually experience a lot of cyber sickness when using this specific interaction technique. And I will later explain to you why that is so. Also, joystick didn't perform too well in this regard, but arm cycling and teleporting had really good really good scores. So yeah, if you just have a look at like the final results or the verdict of this, is that arm cycling and joystick seem to be like good options actually for locomotion techniques using the controller, because they had a good enjoyment level. Weren't too tiring sometimes. Like, I mean, arm cycling was tiring, but it still had a very less cyber sickness, and both had pretty good control. And with that, we also complete the locomotion techniques. And now let's use the remaining time to have a quick look at the VR challenges. So here's like a general overview of the virtual reality challenges. So currently, the research is limited by the field of view. Because the field of view is limited, we have a high price. Also, the uncanny valley is still an issue. I don't know if you know it, but basically it kind of refers to that if you try to make avatars, for instance, look more human, like in the beginning, it will work well, but at some point it will just like the curve will just like fall down, because you will get into a scene where they kind of look a little like too unreal or very creepy. So if you just like put uncanny valley in Google, you will understand what I mean. So also there are currently limited use cases for consumers, because it's mostly about like for by gamers for entertainment. The aesthetics and the comfort are still something we have to work on. Also, precision and control is not that well, depending on the interaction technique. Tracking is something we have to improve on. And then there's vertigo and sickness. And vertigo and sickness is what affected the point tagging method the most. And the reason is that if you have a look at the vestibular system, the semicircular canals in our internal ear determine how our head is rotated in the world. So that means that if we experience contradicting information from other senses, that will lead to vertigo, which is this feeling of dizziness or cyber sickness as we have. So what we have to keep in mind when designing for virtual reality is that moving in a direction that you are not facing will cause sickness. And this is what happened for point tagging, because in point tagging, you basically grab the scene and you pull it towards you. So you could basically even just like keep looking straight, but pull it from the side, and the entire world would start rotating, and it's not aligned with the direction you're moving to. So this is why people experience this sort of sickness. And yeah, with that, we already have concluded the contents for today. But I would like to like quickly do a summary of this entire week's content. So what we did, or what we learned, is we started off with having a look at the perfect virtual reality. And in that regard, we also had a look at a couple of definitions. One was virtual reality is a simulator 3D environment that enables users to explore and interact with virtual surrounding in a way that approximates reality as it is perceived through user senses. And then we had a look at keywords which are important for virtual reality. Those were immersion, imagination, and interaction. We had a look at 3 degrees of versus the 6 degrees of freedom for interaction. We introduced presence and orientation as further important keywords, and also had a look at the different illusions, such as the place, plausibility, and embodiment illusion. Then we continued with a brief look at the history. We had some different milestones, which we had a look at, such as the Sensorama, the sort of Damocles as the first VR headset. We looked at video plays for projections. We saw that the term wasn't coined until 1987. The first entertainment system was actually introduced in 91. We saw the cave as one of these projected rooms. And then we had the virtual Vietnam for the PTSD treatment, and the momentum gained within virtual reality through Facebook buying Oculus VR company in 2014. And then finally, we ended last week, no, not last week's, this week's, but Tuesday's session with the classification into non-immersive, semi-immersive, and fully immersive. And then again today, oh no, that was also Thursday. We had also a look at the reality virtuality continuum, where we saw that augmented reality, the difference between augmented and virtual reality, basically, that virtual reality solidly consists of digital objects, while augmented reality is when you have the real world and you just superimpose virtual content on top of it. And with that, we finished Tuesday's session. And then today we continued with the methods for virtual reality, which were simulation-based, avatar image-based, projector-based, desktop-based, and head-mounted displays. Then we had a look at multiple application areas and did a deep dive for the automotive industry, the healthcare industry, and education and training. We had a look at the different locomotion techniques, walking in place, and controller-based walking. I had an evaluation of the different controller-based walking techniques, and then finally concluded everything with the VR challenges, which, yeah, I basically just named. And with that, yeah, I conclude today's session, and I hope I was more or less in time. I have no clue, I'm sorry.
Thank you so much. Very nice, very interesting, very streamlined. Right, and as usual, we now proceed to the discussions section, where you're encouraged to ask questions or to give comments about the content, not about the quality for now. So, yes, Pietro.
So in the paper that you presented about the hunt, do you know what survey was used to evaluate the VR movement systems? If it was particular survey used also in other research, or a specific one that they used in only that one?
Do you mean the one from like the not the brain one, but the other one with
treasure
the
hunt.
locomotion techniques?
Yeah, exactly.
I think depending on the variables, like for so it's been a while I've read it, but I think they kind of used surveys for like at least the sickness part of yeah, I think like even for the enjoyment, like most of the things I think were answered based on the survey, but like time or something you could record during the interaction itself. I wonder what else was there. There was
but my question was specific to the survey. If you know if it was assessed survey, I mean something that is popular in literature and reused, like I don't know, for example, the SASSI questionnaire.
Give me 1 second.
Yes.
Okay, I'm not too sure about this specific paper, but I have learned that in respect to virtual reality measurements, there's the IPQ, which is used often for measuring presence. I don't know if you know that, but that is also like a kind of established scale which is used for within virtual reality. But for that, I actually have to look it up. I will see if I can find the paper and maybe link it in here.
Frankly, I think this is a very specific question which could better be discussed separately.
Yeah, I agree.
Thanks for asking the question, but I'd like to move on for now and encourage you to continue that direction separately. So, are there other questions or comments? Oh, there's the link already. Okay, that was fast. No questions? Well, one question that sprang to my mind is virtual reality seems to focus on visual perception, and but for full immersion, maybe more senses could or should be simulated or addressed. So, for example, standard is of course also to have audio to complement the visual perception, right? headphones that is common gaming technology. Maybe that's so standard that it doesn't even need to be mentioned here. But I guess you mentioned haptics, right? So that means like resistance, force, right? Maybe using some gloves or so, right? Some to simulate force, one needs some external gears, I guess. But my curiosity is about other senses, right? There was a time when smell cinema was popular. Movies that would exhibit smells. It didn't last long, but that was maybe, I think, 30 years ago. Maybe it's time for revival of that. And then there's other senses, maybe beyond the gloves provide sensual feedback to the hands and fingers, right? But for full immersion, maybe also other parts of the body could be kind of provide feedback, or people strap into some gear that is then kind of spun around. This is, I think, for racing simulators. This may be the latest cry, where, for example, yeah, you know all this from flight simulators, right? So when the plane, the pilots and the plane dives or so, then also the simulator simulates the lag or the increase in acceleration. So what baseline is, there are many more senses that could be simulated and are occasionally simulated. Right, so yeah, that's a very question. If you want to comment on that.
Yeah, I think the five senses I think are like visual, audio, auditorial. You can taste, you can feel, or you can like smell. And I think the most intuitive or the most important one is the visual one, which is why it is so commonly implemented. But we have seen examples such as like the surgical training, for instance, where audio is also employed as to enhance this visual feedback that is provided. But I think currently, like after hearing and seeing, I think haptic is like the most important step to cover for now, because in the scenarios or the use cases that virtual reality finds currently, which is mainly learning or simulation, so far I think smelling or tasting is not as important compared to the other senses. And as we haven't yet bridged the haptic issue, I think that this is like the main direction we are going to. And it, like, as I said, really depends on for what we even need the smelling for. Like if we would have this perfect immersion, then we could be walking around in a park and then like smell the spring or something, or the grass or something, to just make it feel more real. But I think we like still pretty far from that direction for now, but hopefully some point we're going to go there.